The videos you are watching were rendered not with any traditional 3D technique, but with AI. And no, not with generative AI like Stable Diffusion or DALL-E. These are Neural Radiance Fields, short for, yes, NeRFs. NeRFs use AI to turn 2D images into fully 3D scenes. After the training, you get an implicit 3D representation of the object that you can query from angles you did not have in the beginning, and view your scene from totally new perspectives. NeRFs train a neural network to understand how light interacts with objects in a scene. It captures intricate details like depth, where you can perceive how far objects are from one another, and reflections, where light bounces off glossy or shiny surfaces, accurately replicating real-world lighting effects. Even subtle, glossy textures like a polished floor or a ceramic vase are handled with stunning realism. So here's how NeRF works. It takes a set of 2D images of a scene, like a Lego toy here, and creates a 3D model. It does this by mapping the scene into a 5D coordinate system, combining the location of 3D space with the direction you are viewing it from. A neural network processes this 5D data, learning to predict two things for every point in space: the volume density, or how much material is there, and the RGB color that is dependent on the view direction. Then, using volume rendering techniques, NeRF combines this data to render each pixel of the image. And since this process is fully differentiable, it can compare the rendered image to the originals, adjusting its model and improving the accuracy to create an impressive 3D reconstruction at the end. The coolest thing about NeRFs is that you don't need a PhD to play with them, and for that, I'd highly recommend NeRF Studio. It's an open source platform that makes work with NeRFs incredibly user-friendly even for beginners. You start by uploading a video of the scene you want to reconstruct. NeRF Studio automatically extracts keyframes from the video and begins training a NeRF model while displaying the evolving 3D reconstruction on screen. You can even pan, zoom, and move around the model using your mouse. Once training is complete, NeRF Studio lets you set up a custom camera path to render your scene into a polished video. And just like that, voila, you've got a stunning 3D reconstruction ready to share. Next, we have the incredible potential of NeRFs across various industries. In gaming and movies, they are transforming the creation of realistic 3D models, bringing scenes to life with remarkable details. While AR and VR could benefit from NeRF's photorealism, they currently don't support real-time rendering, or at least not in high quality, limiting their use in immersive experiences. However, NeRFs excel in virtual tourism and digital heritage, allowing us to explore remote or historical sites in stunning detail, and preserving these locations digitally for future generations to experience and learn from them. Now let's talk about the fuel behind the fire, the NeRF Dataset. As we said, NeRF converts 2D images to 3D scenes, and for that we need images, but also camera focal length, position, and orientation, or shortly, the camera poses. A NeRF dataset therefore consists of the set of images and their corresponding camera poses, usually stored in a JSON file format. Regarding the details, NeRF dataset is only about 5 GB. That's pretty small for the dataset, but it's packed with diverse scenes designed to tackle some tough challenges like handling occlusion, variations in lighting, and reflective surfaces. The dataset is divided into 3 subsets, each targeting a different skill set for NeRF. First up, the Diffuse Synthetic 360 subset. This one features 4 simple Lambertian objects. Think of them as basic shapes that don't reflect light. The camera moves only in the upper hemisphere, focusing on teaching NeRF how to handle basic geometry and smooth lighting. Next, we have the Realistic Synthetic 360 subset. Here things get more challenging with 8 complex non-Lambertian objects, which are objects that reflect light and have intricate textures. The camera goes full 360, capturing all possible angles. This subset trains NeRF to manage occlusions, detailed textures, and tricky lighting scenarios. Finally, we have the Real Scene subset. This includes 8 real-world scenes captured using a standard phone camera. This subset introduces NeRF to wild natural lighting, shadows, and the kind of noise you only get from real-life conditions. It is the ultimate test for NeRF generalization. Next, let's take a moment to examine NeRF under the FAIR principles. FAIR stands for findable, accessible, interoperable, and reusable. Basically, it is about making sure you can grab a dataset, use it, and create something cool without all the hassle. NeRF checks the box for findable. The original datasets are available online, including platforms like Kaggle or the project's demo page. It is also accessible, meaning you can use it without jumping through hoops. Most datasets come with clear licensing, making it easy to check how you can use them. As for interoperability, NeRF datasets are typically available in formats that work well with popular tools and operating systems. After all, we have a bunch of images and an accompanying JSON file. Additionally, NeRF is reusable. Once you have the data, you can tweak it or adapt it to your different project needs. Finally, with NeRF ticking all the right boxes, we can say that the dataset is fair enough. Our next destination is successor datasets. The original NeRF dataset excelled in two constraint settings. These are synthetic objects without any background, viewed from all angles as shown in the screen, and real-world scenes where the camera is always facing the same direction. MIP NeRF 360 came to deal with unbounded scenes where there is an object of interest and there is detailed and interesting background and the camera rotates around the object. The dataset consists of 9 challenging indoors and outdoor scenes. Moving next to the Tanks and Tempos dataset. The Tanks and Tempos dataset is a key benchmark in the world of 3D reconstruction. It is designed to test how well algorithms can recreate complex real-world scenes. The dataset features a diverse range of settings, including outdoor structures like tanks and intricate temple ruins, as well as detailed indoor environments. What makes this benchmark stand out is its use of high-resolution video sequences as input. These sequences capture scenes from multiple angles, providing a rich dataset for models to work with. The ground truth reference models created using advanced laser scanning technology ensure that the reconstructions are evaluated with exceptional precision. The evaluation focuses on metrics like accuracy and completeness, comparing how closely the reconstructed models align with the actual scenes. This makes Tanks and Tempos an essential resource for researchers aiming to refine their methods and improve the quality of their results. By presenting realistic challenges and high-quality data, Tanks and Tempos continues to drive innovation in the field of 3D scene reconstruction, encouraging the development of more robust and detailed pipelines. Did you know that NeRF datasets are not exclusive to the NeRF technique? Once you've experimented with NeRFs, I'd recommend also exploring 3D Gaussian Splatting. It's a technique released in 2023. You can also try it by visiting Luma AI Labs, which offers an excellent app. Just capture a 360 video and upload it like I'm doing here, modeling a lovely site in our beautiful city of Erlangen. Instead of neural networks like in NeRFs, Gaussian Splatting uses 3D Gaussians as flexible and expressive scene representation. It is trained in the same settings and tested on the same datasets we've discussed. Quantitative results show it can achieve equal or better quality than the highest performing NeRF models while maintaining fast training and order of magnitude faster rendering. We won't go into the technical details here as that's beyond the scope of this video, but it's an exciting area to explore. And with that, we are almost at the end of our video. This video was brought to you by Mayin Al-Karrar as part of the series Fantastic Datasets and Where to Find Them. I hope you really found it very informative, and I would like to thank you for your attention and patience.